Step outside on a normal morning, and the sun feels almost boring. It is bright, hot, and powerful enough to run every weather system, ocean current, and green leaf on Earth. It is also small enough, stable enough, and far enough away that life can treat it as background. Now replace it with Betelgeuse, the red supergiant in Orion, and that background disappears, not because Earth gets a prettier red sunrise, but because Earth is no longer outside the star at all. Betelgeuse is not just a bigger sun, it is a different category of object. Our sun is a main sequence star. Betelgeuse is a swollen red supergiant near the end of its life. Its exact size changes because its outer layers pulse and shift, but a common estimate puts its radius around 700 to 1,000 times the sun's. Put that at the center of our solar system, and the star's surface would extend past the orbit of Mars. Earth, at 1 astronomical unit, would be deep inside it. That is the first major correction. The usual mental picture is Earth orbiting a giant red disk in the sky. That would only make sense if Earth were outside the star. In this scenario, Earth is not outside. It is inside the outer envelope of a star. So the real question is not whether Earth would be warmer. The real question is how long a planet can remain a planet after being embedded in a red supergiant. If this swap happened instantly, you would not see it right away. For about 8 minutes, the last sunlight already on its way to Earth would still arrive, because light needs time to cross the 150 million kilometers between the sun and us. Then the change would hit. But even that phrase is too gentle. The change would not be like dawn. It would be like reality being replaced. The sun currently delivers about 360 watts of power to every square meter facing it at Earth's distance. Betelgeuse is cooler at its surface, glowing reddish-orange rather than yellow-white. It makes up for that with absurd size. Overall, it shines tens of thousands and likely around 100,000 times more brightly than the sun. At Earth's current distance, that means the planet would suddenly be receiving something on the order of 100,000 times more total energy. That is not a heat wave. That is not a climate crisis. That is a materials problem. Upper atmosphere would absorb a catastrophic flood of radiation and heat almost immediately. Sky, if it could still be called sky, would brighten into a red-orange glare mixed with the glowing gas of the star around us. Earth's atmosphere would expand violently. Weather would stop being weather in any recognizable sense. Clouds, winds, and storms depend on differences between warm and cool regions. This would be more like the entire planet being pushed toward furnace conditions at once. The oceans would not politely evaporate over centuries. They would flash into superheated steam. Lakes, rivers, soil moisture, and polar ice would all go the same way. Plants would ignite or carbonize. Animals, buildings, forests, and cities would be destroyed long before the rocks beneath them finished their own transformation. At those energy levels, Earth's surface temperature would race far beyond the boiling point of water and keep climbing toward the temperatures where many rocks begin to melt, soften, rise, and that is only the radiation problem. Earth is also sitting inside Betelgeuse's expanded outer atmosphere. A red supergiant's envelope is much more diffused than the dense layers deeper inside a star, so Earth would not be instantly crushed the way it would be inside the sun's core. Diffuse is not good news. It means Earth is moving through hot stellar gas rather than empty space. That gas creates drag, and drag, when your planet is trying to move through the atmosphere of a star, is a terrible thing to have. There is also gravity. Betelgeuse is far more massive than the sun, likely around 15 to 20 solar masses. Earth's present orbital speed, about 30 kilometers per second, is tuned for 1 solar mass at 1 astronomical unit. Around a star 15 times more massive, that speed is far too low to maintain a circular orbit. Earth would begin falling inward almost immediately, curving into a tighter path, while plowing through stellar material that steals more of its orbital energy. Even if the heat did not kill the planet first, orbital mechanics would finish the job. Mercury and Venus would not even deserve separate chapters. They are much deeper inside the envelope and far closer to the center, so they would be destroyed even faster. Mars would also be inside the star, though nearer the bloated outer edge, depending on Betelgeuse's exact radius at that moment. The asteroid belt would no longer sit next to a modest yellow star, face a supergiant radiating enough energy to radically alter or destabilize objects that had survived there since the early solar system. Earth itself would pass through stages, but they would happen on brutal timescales. First comes atmospheric overheating and collapse. The oceans go. Then the crust begins to melt on a planetary scale. The distinction between continents and seafloor disappears. The planet becomes a glowing, partially vaporized mass wrapped in rock vapor and stellar gas. Any trace of the biosphere is gone almost immediately in geological terms, and in human terms far sooner than the sentence describing it. There is a temptation to ask whether humans could survive underground, underwater, or in bunkers. Underground shelters work against surface hazards that are limited in duration or depth. This would be continuous global energy input from a star surrounding the planet, plus a world whose atmosphere and hydrosphere are being stripped apart. The oceans would not protect you because the oceans would become steam. Rock overhead would not protect you for long because the rock itself would be heating, cracking, and eventually melting. This is not a shelter problem. This is your planet has been inserted into a star problem. If Earth survived as a coherent object for any meaningful time, it would do so as a dying ball of magma spiraling through a stellar envelope. Atmosphere would be peeled away. Material from the surface could be stripped into the star around it. The Earth we know would stop existing first as an ecosystem, then as a surface world, and eventually as a separate object. Destruction would not stop at Earth, because replacing the sun with Betelgeuse would transform the entire solar system. Jupiter, which now sits about 5.2 astronomical units from the sun, would suddenly receive thousands of times more energy than Earth gets today. Its cloud tops would heat dramatically. The icy moons around it, including Europa and Ganymede, would be blasted by intense radiation and warmth. Saturn's system would also be cooked. Titan would no longer be the cold orange moon of methane rain and hydrocarbon lakes. It would become a heated laboratory of chemical chaos. Even the distant outer planets would not escape. Neptune, roughly 30 astronomical units away, now receives so little sunlight that noon there is dimmer than twilight on Earth. But under Betelgeuse, even Neptune would receive well over 100 times the sunlight Earth gets from our present sun. A planet on the edge of our familiar solar system would suddenly be more strongly heated than Earth is now. The cold architecture of the outer system would be erased. That also means the habitable zone, the rough range where liquid water could exist on a planet's surface, would move drastically outward. In a purely abstract sense, regions that are currently frozen could briefly become warm enough for liquid water. But this is where the details matter. Betelgeuse is unstable, extremely luminous, and nearing the end of its life. It sheds mass, drives powerful stellar winds, and does not offer the kind of billion-year steady output that helped life evolve around the sun. Yes, the Goldilocks zone would migrate outward, but it would do so around a star behaving less like a reliable furnace and more like a giant, leaking, aging engine. And then there is the supernova question, because Betelgeuse is famous partly for being a likely future supernova. The key word is future. In astronomical terms, Betelgeuse may explode soon. In human terms, soon could still mean tens of thousands of years. So the supernova would not be the first thing to worry about. Everyone on Earth would already be gone, and Earth itself might already be destroyed or absorbed long before that final explosion. If Betelgeuse eventually detonated from the center of our solar system, the remaining planets, moons, and debris would be blasted by one of the most violent events a star can produce. So what would it actually be like if Betelgeuse replaced our sun? The honest answer is that the part humans care about would be very short. We would not get years of red sunsets. We would not adapt to a hotter climate. After about 8 minutes of normalcy, Earth would find itself inside the envelope of a red supergiant shining roughly 100,000 times more powerfully than the sun, under the gravity of a star many times more massive, moving through hot stellar gas, losing its oceans, its atmosphere, its crust, and eventually its identity as a world. Betelgeuse looks beautiful from Earth now because it is safely hundreds of light years away, a reddish point in a winter constellation. Put it where the sun is, and the familiar question changes. It is no longer what would our sky look like, it is how long before our planet stops being a planet. The answer is not long. Earth would not orbit beneath a giant red sun. Earth would become debris inside a star.